So I'm going to go and just quickly wrap up on methods. There's one thing we didn't get to cover last time, and we're going to really briefly touch base about this big concept called inheritance. It's a huge topic we can't cover today, but we do need to go mention it because it is a prerequisite for this last part, sprites, a concept that we're going to see in Pygame, and that's going to really help with making your games later on. So methods, I want to go and give you a quick reminder what a method is. A method is just a function, but it's a function that belongs inside a class. So left side, I have an approach that does use methods. Right side, I have the same thing, just not using methods at all. The method belongs inside the class. So you got class person, and if you want to go and get their age, you can go and say def get age. First parameter is self, and then you can go and do anything you want in here. It's just basically a traditional function from that point onwards. And then afterwards, you can go Sam equals get a person here, and then you go Sam dot get age, open bracket, close bracket, no self needed. Compare that to a function over here. You see that it's just the same stuff, but just kind of organized a little bit differently. Get age, you need to go and pass in a person instead, which is, in my opinion, not as nice and clean because you have to go and ask for the person rather than asking for just getting a person's age. It's not as intuitive. Again, only way to really appreciate how methods are truly useful is through practice, practice, practice. And that's what the next 3 sessions are all about. So I know that some people are still confused about self, and I don't blame you. It's still one heck of a tricky thing. So the self is really referencing the object, the one that we're currently talking about. When we're in the middle of creating something with our class, we have that thing is the self. When do you use self? When you have a method and you're defining it, the first parameter is always going to be self. It gives you access to self.x, self.y, etc. That's how you define it, right? You're going to also see this inside your initializer, aka constructor, and you're going to see this inside your methods. In the meanwhile, calling a function, you don't need to use self anymore. You only just need to go and automate, or just simply say, get the object, and then call its method on there, and then just skip the self keyword. It's automatically going to get put into there. But I lied a little bit. There's one tiny caveat on that. And that is, what if we want to go and use self to access member functions? Review's finished. We're moving on to the last new part of the conversation on methods here. Basically, the self keyword lets us access anything from within our class, right? Which means we can go and actually access within it our own methods. And off the top of your head, this might not sound like the most useful thing. It might sound like, sure, it's another gimmick, but I'm going to promise you it's actually super useful for keeping your code organized and keeping it nice and clearly set up. After all, why do we have functions, just that you remembered from your original stuff? Functions are to go and handle repetitive code. It's to go and keep things organized. Why do we have methods? Functions, but for classes. Why do we have access to methods inside our classes? Because of the exact same reasons. We want to go and clean up some repetitive code. We want to go keep things organized. And we get the benefits of methods on top of this. We get to go and keep it neatly packed up inside our ball. So let's take a look at this quick example over here. I'm going to have a class ball, nothing out of the ordinary. That's just going to draw a little circle on my screen here. I'm going to initialize it. I'm going to go talk about just the y variable today. And I want to say, I think it might be useful if we make this ball be able to travel up and down. Maybe I'm thinking of like a balloon in my head at the moment. Your balloon can travel up, your balloon can travel down. It's that being said, though, it's useful to say just travel in the y dimension. I mean, that's how you would do it, but that's not something that the user would care about. How? Yes, you want the y. What are you providing for the people using this? No, you don't need to go into that level of detail. So I'm going to go and take all this excessive detail. I'm going to wrap it up and hide it inside another method called move y. And so I say, I want to say move up. Okay, when I move up, I'm going to say self dot, and then I'm going to call my method down here, move y. And it's just like calling an object, no self keyword is needed right here. That's the self keywords already right there for you. Moving down, self dot, move y. And in theory, this means that nobody ever needs to go and use move y except for these move ups and move downs. Sure, sometimes there's exceptions. You can let other people also access move y, but the intention is that we're going to go and keep it nicely packed inside this ball here, or this balloon, or whatever example you have. When you get really large code, you're going to want to start breaking stuff down into smaller pieces. We'll revisit this idea a little bit later, but again, the only way to really demonstrate this, the full power of this, is through lots of practice and through really big examples, neither of which I can really provide as a speaker here. So I'm going to start us off. Take a quick question here. How many times am I missing the keyword self in this code? Take 2 minutes, read it over carefully, and try to figure out every single spot. Remember, defining a method, use self. Calling a method, don't use self inside the parameters. Okay, try it out. 2 minutes. Okay, how are people doing with that? Going to give it the last 10 seconds to go and close it off. Take a look, take your best guess. All right. Well, this one's interesting. This is a little bit different than our usual ones because we didn't, today, normally everybody gets, the majority gets the right answer, but I think this is actually interesting that not everybody got it. So let's go take a quick look at this. How in the world am I supposed to go and count this up? I'm going to need to go pull up the slides on my own personal screen or on my second screen. I'm unable to go and see it through all this crowd here. But when we're talking about our class fruit, we got a fruit name, we got our color, we got a bunch of methods. We're going to have to go and see how this plays into here. I'm going to go and let's just go fruit up high. And I'm going to go class fruits. And when we're creating the fruit, we don't need anything there. Nope. But we're going to go def double underscore inits. And I hope I drill this into your heads. What's the first parameter on this? Self. Excellent. We got the keyword self. That's the first one we're going to see here. We're going to have the color. We're going to have the fruit name. And so I'm just going to mark here, colon, number one right there. And then number two, we're going to have to go color equals color, fruit name equals fruit name. And we see that there's going to be two more right here. It's going to be self.color. It's going to be self.fruit name. So that puts our count up to 3. Right? Now we're going to go get into the tricky territory over here. We got this eat, we got bites, and we got crunch, and all this fun stuff going on down here. Def eat. This is a method. So when we are creating methods, where do we go and put that self keyword? Right up in the front right there. We're going to go and add the keyword self right here. That's going to give us number 4. We're going to also have this, I'm going to come back to this in 1 second. We're going to have def, I believe it is just bytes. There it goes, byte, open bracket, close bracket. Again, another method. What's the first parameter on the list? Self. Excellent. You guys are too good at this part. That's the easy questions. Okay, and then we're going to go print crunch. We don't need anything, any self there. We're good. Here's the one that I think a lot of people got caught up on. Byte, right? We take a look around. Where is this byte defined? This byte is defined inside our fruits. How do we go and access that? We're going to go and need another self keyword right here. So I know that that's number 5. The number 6 entry is going to be this one, self.byte. When we're calling a method, we're always going to need the object that's calling it. The object, in this case, has been given to us as the self. It is bundled up inside this fruit already. If we want an example that is not the fruit, I'm going to go all the way out here. This is outside of it, and we're going to go apple is equal to my fruits, and I can open bracket, close bracket. See, I only need the color and fruit name, so I'm going to go red, and I'm going to go apple. I'm a little bit lazy with my typing. When I need to go and call eat, that'll be apple.eat, open bracket, close bracket, nothing. When I want to call byte, that's apple.byte, open bracket, close bracket. So if I want to call eat, though, let's just go quickly inspect what that is. Apple, eat, goes inside here and says, what's a self? The self's automatically passed in. It's this apple that we're automatically passing in. All right, we want to go call this byte part here. How do we access that? We're going to need to go and say self.byte in here, and we're going to grab that and plug it in. So that's just something to keep in mind. I'm not going to go and drill over that too much, but I think it is just essential to use. On to the next topic, inheritance. I wish that we could spend lots of time on this, but honestly, if you want to spend time on this, there's an entire university class dedicated to teaching how to use this effectively. I'm going to skim the surface instead. Really, in short, inheritance is another way how to go and make sure that you don't repeat your code. Inheritance lets you go and inherit or borrow and reuse all the stuff, all the variables and all the methods from another class. So in my particular example here, let's go and say we got ourselves a snake. I'm particularly fond of my snake examples for the last few weeks. We got our snakes. They can go and they can hiss. They can go and slither. They got what, one single 0-limb shape here. And that's your good old traditional snake. But what if I wanted to go and get like a python? What if I want a rattlesnake? What if I want a cobra? What if I want to start differentiating all my different snakes here, all these different subspecies of them? Well, they're all snakes. That's a parent classification that we can go and give all these things here. But each individual species down here needs their own unique ways of handling certain problems, right? I don't want to go and say snake.rattle this little rattler here, because if we take a look, this snake has no rattle to rattle. This rattlesnake has a rattle. That's excellent. So we can say the rattlesnake has a rattling, or in the meanwhile, though, this snake up here does not. Other things to look at, this rattlesnake still has this big 0-limb thing slithering in the desert like all other snakes. It should be able to just borrow that same code that we've already spent so much effort to go and define what a snake is. So let's go and take an example together. I'm going to go and type this out from scratch so you guys can follow along here. I'm just going to go create a brand new file here, and we're just going to start with our first file, snake.py. So inside snake.py, we're going to just go create a conventional simple snake. There's nothing going to be too scary about this. Class snake colon def double underscore init double underscore, and first keyword as usual, self. Take a look at our example here. That's name, that's color. Pardon me. I'm going to put that in here as well, name, comma, color, colon, and I'm just going to go and say self.name equals name, self.color equals color. If you're lazy, you can just use single letters instead, but I'll type it out in full. We want to go and say, how do snakes move? F, move. First parameter, as usual, is going to be self. And we're going to say that all snakes slither, right? So let's go and print slither. Here we go. We can always just simply go and prove this works. I'm just going to press enter a couple times, get outside of my class, and we're going to go and say, oops, equals snake, and I'm going to say Sam, and I'm going to set the color as green, and I can go s.print, oops, s.move, open bracket, close bracket, and this should be as everyone expects. some of the nice and simple stuff going on right here. So take a second to go and type all that up because we're going to jump into the next part here, the fun part. We're going to go and create ourselves a rattlesnake on top of this. I'm going to go create another new file here, and I'm going to call this rattlesnake.py. Typically, it's conventional that you make one file per class here, and we're going to stick with that. I'm going to need to go and grab that snake that we've just created. So from snake, import the class snake. And now we can go and get started here. We're going to say class rattlesnake. And the very first difference appears. I want to say that this rattlesnake inherits from the parent snake. I'm going to open brackets here, and I'm going to go and type in snake, the class name here. So when you are creating a brand new rattlesnake, please also go and create the parent snake with it. Def, double underscore, init, double underscore. Let me just go and make sure I'm following my example correctly here. We're going to have our self, our name, our color. We're also going to go and add a sound effect here because rattlers have some really cool stuff with that. So I'm going to go with my self, color, name, sound. And I'm thinking, oh, wait a minute. Well, I could theoretically just go like self.color equals color, self.name equals name, self.sound equals sound. But honestly, I'm looking at this list over here. This one makes sense. Self.sound equals sound. That makes sense. It's brand new. But these other two, I thought I already typed those out. I already have my own snake that's over here. And the entire purpose of this is to go and cut down on the amount of code. After all, my snakes should go and have in common a color. All of them should have a name. So what I'm going to go and do instead is delete that code. And I'm going to go and type in super, open bracket, close bracket, dot, double underscore init, open bracket, close bracket. This is looking a little bit funky, so let's go and take a moment to read this over carefully. We're going to take a keyword here, super. This means create, go to the parent snake itself, and it's a function. And then afterwards, that is basically like taking in the self here. It's no longer the self, it's more like the parent, lift it up. So what you can really think of as one way is that you can think of this super call. It kind of replaces parent self. And then we can just imagine that that gets subbed in. So now it would be the parent self dot double underscore init. Oops. Somebody has mentioned to me, I screwed up my parameter order, which actually is a little bit important here. I'm going to flip them around real quickly. Name, comma, color. Make sure that I don't have any inconsistencies there. Thank you to the mentor who just gave that little tidbit here. What I'm also going to need to do with my inits, I need to go and say I am basically calling this constructor. I get to skip the self because I'm using the parent self now instead, but I need to go pass in its name. I need to go pass in its color so that it can do all the complicated stuff that my parent snake can do. So I'm going to go pass in my name. I'm going to pass in my color. Bada bing, bada bam, bada boom. We are done with that. I'm going to rearrange that line just to make it a little organized. And there we go. Let's read it over one last time. Super gets the parent self. It goes and initializes it. We are doing the exact same initialization process over here. So the method needs a name, it needs a color. We're going to go and pass in name. We're going to pass in color over here. And now we can go and add in the new one, self.sound. Excellent. So what we're also going to do, we're going to also add in one little touch of fun here, def rattle. And we're going to need to go and add the self keyword here. This one refers to the rattlesnake, not the parent snake in this case here. And when we're going to go and do that, we can just simply do print rattle, rattle, or rattle, rattle, or if you're more specific, if you want to use that sound variable, what probably makes more sense is print self.sound. So taking an example over that, let's go create ourselves a brand new rattlesnake. So I'm going to go Rodney equals rattlesnake. And I'm going to say the name. Yeah, I just said it, Rodney. I'm going to set the color to be orange, and I'm going to set the sound to be okay. And what I'm going to do with Rodney here is I'm going to use, well, this rattle sound effect. We know that this one should work. Rodney.rattle. This is just like as if we had any other regular class here. I'm going to save that, and I'm going to run that. And we got and we also got the other part here. We got the slithering going on as well. We got the movement happening as well. 1 second, I wonder if I did screw up a line there. I'm going to say that what I should have been able to show off is Rodney also has all the access to its parent. So it has access to a name. It has access to everything else underneath it. So print Rodney's name. We can go and print Rodney.color as well. And we have access to all these things that the snake has as well. So we got Rodney, the orange one. And we can even say Rodney.move. We can go and ask it to go and use its parent here. It says, when I want to go and move the parent here, take my snake, my rattlesnake, and take a look over here. I don't see it inside here, so I'm going to go jump inside my snake. And oh, there it is. There's the move. And when I put it in here, I'm going to go and start slithering. And I figured out why we had that example. We had our snake little S, letter S that was running behind. There we go. Snake, I'm going to delete that. This is why you don't put code in multiple pieces of code in the same file. It gets to some real big confusions. Over here, Rodney rattles. Rodney rattles with the sound effect that he has. Rodney has a name, the same thing as every other snake. Rodney has a color, and Rodney has access to his parents' slithering method. It's beautiful. Parents are passing down everything that's wonderful to their children here. I hope that at least you guys can relate to that somewhat with your family. Moving on. Oh, I already kind of talked over this point here, but I did want to just recap here. We had Rattler, that's my Rodney example here. When Rodney goes and rattles, well, a rattlesnake has a rattle. We can go and do it here. But when Rodney wants to talk about his name or Rodney wants to move, Rodney does not have it as a rattlesnake. Rather, the snake parent has it. So it's going to go and take a look and say, oh, skip this rattlesnake step, go straight inside the snake, find it there, and find the move function inside there. That's exactly what we saw while we were printing out this code. That being said, I'm going to give it to you guys. Instead of going snakes and rattlesnakes, how about we do animals and cats, the classic example. We'll try taking 15 minutes to try this out. How are we doing? We got everybody back into here? Excellent. Thanks all. Glad to see you guys again. How are you guys doing? How many of you guys were able to successfully finish the exercise? Nice, we got some people who were able to finish. Awesome. Awesome, awesome. Okay, that is awesome. I'm getting a lot of people resonating around with me. For those of you guys who were not able to finish on the closing end, let's go wrap this up real quick. It looks like you guys have actually a really comfortable handle on this. I'm glad to hear that. So let's go and run through this real quickly here. If we want to go and create our animal, we're going to have to go and first start with an animal class. Animal.py. And I'm going to go class animal. And I'm going to go def init double underscore init, open bracket, self is my first keyword. And as my second keyword, I continuously keep forgetting what we have, name and sound. Okay, and we're going to go and plug those in real quick. Self, comma, name, comma, sound, and we're going to go, and then self.name equals name, self.sound equals sound. Okay, and then we're going to have self.makeSound. Make sound is going to be that self keyword here, and we're going to go self or print self.sound. Nothing out of the ordinary here. Just to go and save myself a little bit of time, I'm going to get cheap and lazy, put it on the same file here. Here, I'm going to go class cat. Everyone loves cats, but I need to go and say inherits for my animal. I'm going to go and put in my animal class right here. I can skip the import because it's the same file. Def double underscore init double underscore self. And then we are just going to go and start with our name here because our cats already have the same meowing sound here. Self.bird. Oops, I got a little ahead of myself here. But I'm going to go super, open bracket, close bracket, dot, double underscore init, double underscore, and I'm going to go and plug into here the name. What's the sound? I'm going to default it to be meow every single time here. So with that, let me go and double check I hit my checklist of everything. We need to go and just simply call out the meow function here. And we're going to go def meow. And we're just going to say to self here. And really at this point here, all we have to do is say go and call that make sound function here, which I believe can look like super, open bracket, close bracket, which is get parent dot make sound. There might be more than other ways to go and solve it. This is the first one that comes to my mind here. So now when we go and start up our class here, kitty equals cats, and then we're going to go Trevor. I really don't know with my names today. And I'm going to go kitty.meow. And pray I did not make a typo here. Let's plug that off. And somebody has very gratefully provided me a couple of answers here as well. So I'm cheating. I'm going to put these answers to the side where you guys can't see them. And basically, that should be basically how, oops, that's why kitty.meow is the needing of its brackets if we want to go and call it. We do that, we got our meow. We're going to move on from here. If you got questions, go back and ask your mentors for sure. But with that, I'm going to need to carry on to the next topic a little bit faster now. We're going to be talking about sprites. Sprites are a way how to draw basically pixels onto your screen here. They have nothing to do with fairies, but I love puns. So now they have to do something with fairies. So sprites basically are another class. Remember how we had animal? Remember how we had snake? We now have sprites as another one. It's just that Pygame has already built it in for us. What do sprites have? They got images, they got rectangles, they got ways how to draw them, they got ways how to update them. They got a lot of complicated stuff behind the scenes here. And I don't want to type that out myself. So I'm just going to go and rely on using the sprite class instead. So the example we're going to build today is called a fairy. And just because I can. And we're going to be able to cover basically just how to get your animation or your sprite drawn. We'll skip the animation step and skip these collisions. And I promise we'll get back to that later. Groups, on the other hand, we will work with. So, wow, that's a lot of text that looks a little bit overwhelming. But we're going to get focusing on these top few lines here. We're going to go class fairy, and we're going to call in the sprite class. I know it says pygame.sprite.sprite. That is just how to go and get the class name itself. And as we did before, we're going to go super.double_init. Let's get started, shall we? I'm going to go and create myself a fairy class. I'll go fairy.py, and I'm going to go import Pygame because we're using Pygame this time. We're going to go class fairy, and I'm going to go and say Pygame.lowercase sprite. That's a module name. Uppercase sprite. That's where it lives inside. I didn't make the rules. That's just how it goes. Def_init. I'm just going to keep it nice and simple and say only the self keyword inside here. We're going to need to go and set up all this complicated stuff that has already existed here. So I'm going to say super, open bracket, close bracket, ._init, open bracket, close bracket. We don't need to pass anything inside. We just need to go and kick it up, get a lot of the complicated stuff up and running. Now comes the fun part. We're going to go get some images involved with this as well. So that's what this next bit of code here is. I'm going to blast through a little bit out of order here. And I'm going to go and download myself a fairy.png image here. Going to click on that link. That's going to take me right to here. I'll pop that straight into chat. Everyone can follow along with me and save that image. Yes, I do recommend this image because size does matter. If you choose one that's a little bit too large, it's going to be a lot harder to work with. So take your image, right click that, save image as, and oh, look, it's already named fairy.png right in there. I've already got this set up on my machine. I'll go and give you guys 2 seconds to go and finish downloading it and putting it inside a folder called assets. So I'm going to go and show you inside here. What have I been doing this entire time? I got session number 4. This is my folder over here. Same thing with VS Code. I created a folder called assets. For me, that was right click, new folder, blah, blah, blah. I chose the name assets. You can choose images. You can choose whatever name you want. But I do recommend don't put your images and your code in the same spot. It gets hard to tell. Inside here, I have it dedicated just to images I have. And for you guys should have only fairy.png dropped inside there. And yeah, name does matter. If you want to make sure that you have the full name extension here, you Windows users can go and press the file name extensions. So I do recommend leaving that on, especially if you're a programmer. It's super useful, and you can know what type of file you have here. It's going to be a PNG, spoiler alert. If anyone knows how to do it for Macs, please leave a message in chat. I unfortunately don't have this memorized off the top of my head. That being said, back at it. So over here, I have an assets folder. I'm going to drop my fairy inside here, and you can even double click, see it straight inside here as well. Let's get having some fun with it. First things first, I need to go find this file. Where does this file live? Well, when I tell my computer to go and take a look for a file, it's going to go and start inside where it currently is. Oops. DA has left some instructions for how to go and get a file name. For now, we'll just trust it's PNG, but I do recommend reading that over if you have not set it up. In the meanwhile, what I'm going to also do is scroll back up. Yeah, a little out of order. I'm going to say as my very, very, very first line, import OS. OS stands for operating system. Windows operating system, Mac operating system, it's going to work all the same here. Linux technically should work as well, but I'm not going to try risking that right now. Image location. Where is my image located? Is equal to os.path.join. And it starts right inside my current folder here. I'm going to say, go inside my assets folder I just created. So create a string, type in assets. Good. Where do I want to go inside here? I'm going to press comma, and I'm going to go and type in the file I want afterwards. That's fairy.png. For Mac users and Linux users, that's going to replace that with a big slash on there. So it goes assets/fairy.png. Windows users has a backslash. If you use it this way with this os.path.join, you don't have to memorize which one it is. And that's always a way you have to keep things a little bit simpler. Now that we got that, I'm going to go and load up my image here. So I'm just going to go self.image is equal to pygame.image.load. And I'm going to go and pull in my image. Where do I want to grab my image from? The image location. That's why we made this variable. Image location. Excellent. And we get to do that. That's just it. And just to go and make sure it runs a little bit faster, this is one little thing you can memorize. So it's .convert_alpha. Convert means go and make it coherent with all the other pixel and image formats. Alpha means alpha transparency, which is really useful when you don't want to have a big black background every single time. So that's going to be that. Finally, afterwards, we're going to go self.rect. Remember this? We always were creating our Pygame rectangles every single time. The rect of the X to Y coordinates, that's going to be the same here. But this time around, I get to do a quick and easy shortcut. I'm going to go self.image.get_rect. That's right. Images have a built-in rectangle ready to go. And it is ready for you to use right out of the box. In fact, just to prove my point, I'm going to go and type in self.rect.x is equal to, I don't know, maybe halfway through down my screen. Self.rect.y is maybe approximately 400 pixels right there. Excellent. We've got the basic template of our fairy ready to go. Afterwards, I'm going to go and take my main copy and rename file. Grab that in, drag it in as usual, or if you're like me, you're going to go and copy paste it right on the spot. Rename that file. I'm going to make my main fairy, and there we are. We're going to get running with this. So import system, import OS. Now we know what that means, and we're going to import Pygame and import. Oops, I beat it from fairy. Import fairy. There we go. We can get running with that. We got the file running. We got everything good to go. I'm going to go into my setup section here. Now, how do I go and create my fairy? A couple extra steps involved. I'm going to have to go and create something called a group. Why do I have to go through this extra process here of getting this thing called groups? Oops, skipping through. It's because groups are the way that Pygame chooses to go and put sprites in. So we got sprites groups, and they're containers that go and hold things. So they hold specifically your sprites. You could think of it basically as a list. That's basically how it works under the hood, but they added a couple extra complicated things in there to make it work well. And with a group, you can go and get like a bunch of baddies walking around the screen like that. So we are going to go and create ourselves a group for our fairy. I know it's just one fairy. Why do I need a group for it? It's because every single sprite needs to have a group. When you want to go and draw it, you're drawing the group and you're going to go and draw it, and that will handle all the stuff inside. When you want to go and update it, do logic with it, start with the group, it'll handle all the little logic inside. All you have to do is just simply plug it into a group. So I know it's a little bit boring to have just simply a fairy of one, but I'm going to go fairies is equal to pygame.sprite.group, open bracket, close bracket. Take a second to look at that. That's pygame. The module name is sprite, lowercase. And the class name is group. And we'll go and create ourselves a Pygame group for that. Well, I also need to go get a fairy to plug into this group. After all, it's just like a list. So I'm going to go fairy equals fairies dot, oops, I cheated, sorry. Fairy equals, just like the regular style there, fairy, open bracket, close bracket. Reading that one more time. We're going to go create our fairy sprite just the same way we have done it before, using good old inheritance. And then afterwards, we are also going to go create our group and putting it all together, fairies.add ferry. So now we basically have a list of that one single ferry. It should look something like this when we are good to go. Coolio. How are everyone doing? Have you guys been able to type along with me? Do you need me to go back on anything? Just type any random letter at all and I'll review anything that we just covered. The rect line for the ferry looks like self.image.getRect, open bracket, close bracket. Any other questions on how to set up our code so far? How does Pygame load the image up? It is going to go and ask your computer, hey, can I go and please request a specific way how to load up these pixels? Do you go and paint it on the screen? The semantic details are far more complicated than I have the ability to even guess at. So I'm only going to give you the brief explanation. It says, please find me a file named ferry.png inside my assets folder. When I find that file, I'm going to go and plug it in and load it up. Yep, the main ferry is just a regular from ferry, import ferry. We're just going to keep the same load or the same thing as usual when we're typing that up. Excellent. If any of you guys are following behind at this point, just poke your mentors, see if they can help you out with any other minor questions of that. I'm going to carry on just because we're a little bit short on time, but I do want to make sure you guys are following along. So there we go. We did the exact same step here. We're going to finally get to the good part. We're going to go and draw out our image. I'm going to scroll down. And yeah, draw is the one that really requires the group the most. But other ones we can skip. This one, though, we're going to care about the most. We're going to say ferries dot group or ferries dot draw. Where are we drawing it? We're drawing it straight on top of our screen here. So take the group of that one single ferry units, and please draw them onto the screen. With that, we should be able to see some fireworks. Boom! We managed to go and get ourselves Navi on the screen. Oh, crap. Please don't copyright me. We got our little ferry on the screen right there. If I want, I can go and start to have some fun with this thing as well. The key one that I want to introduce is the section called updates. So updating here is going to look like ferries.updates. And this is going to basically do all the logic that we want to apply to our class. Where does this come from, though? What logic are we applying? Good news is we get to make it ourselves. Well, bad news if you guys are lazy programmers. But I'm going to go back inside my ferry.py class over here. I'm going to type in def update, open bracket, self, colon. And with that, we can now start defining anything we want. We could do really anything. We can have some fun with this. I'm going to make my ferry float off to the left. Self.rect.x minus equals 1. Once again, taking a look over here, we got the draw section. That's ferries.draw screen. Inside the update section, we put in our first code. We're going to say ferries.update, and it's going to say for every single ferry in my list, please call the update function over here. So that's update self, and I'm told it, please travel left. That is what I want to do when I update it. Let's run that off, see what happens. And we got our ferry sliding across the screen. Excellent. We are going to make some good progress here. You can actually access the regular ferry, this one, as usual. In fact, if you want to do anything else other than what I just described, you're going to have to go and use that one individual ferry or your own for loop. So what can we do with it? We can go and actually make that ferry travel around. I'm going to go over here. I'm going to go to ferry.py, and this is self.moveSpeed. I'm going to set that speed equal to 5. It's not strictly required, but I'm going to use this number here to go and dictate how fast it travels when we go to our keyboard events. And this is the same stuff as last time here. So I'm going to go and blast this in real quick here. I'm going to say ferry.rect.y minus equals ferry.moveSpeed. And then, all right. Maybe I could go and type it like that, but I realize I was just typing as fast as I can without thinking it through. Sure, that works, but what about all that good old method stuff that we learned last time? Hey, perfect opportunity to bring it back in. You could go and put in any method you want. You're not restricted to just init and update. You could do def foo, for example. self x y. That's covering the exact same stuff that we talked about last week here. So self.rect.x plus equals x, self.rect.y plus equals y. And now we have a move function here that can keep it organized. So we take out this ugly mess, and I can go fairy.move. And I'm going to say 0 for the x dimension, and I'm going to say negative fairy.speed or move speed. There we go. Copy paste this line into here. Don't worry if you guys aren't able to keep on up with the typing speed here. This is just simply to prove that this is possible. My move speed for the left, I want to set that as a negative here and say that there's 0 on the movement here. And at the end, fairy.move the right, which is the easiest one. Fairy.move speed, move speed 0, 0. And with that, should be able to, cool, control it with a keyboard. And that update is still traveling along, slowly making it slide over to the left, which, I'm going to ask a question here, see if anybody is on top of their game right now. Sprites. What are some other examples that we could use sprites for? I'll give you a hint. Player is one of them. What else would be really useful to draw on your screen for your game? You got, okay, backgrounds, that's an interesting. Enemies, okay, interesting. We got props, we got platforms, platforms, tile maps. Okay, sounds like you guys know how to play your games, especially your good old retro 2D games. How about like this moving around here is probably not all that useful for me with a player. It's kind of irritating to watch my player slowly slide around. Are there any examples where it might be useful to have something sliding around back and forth? What kind of sprite from that list of examples everyone was tossing around would be really useful to have slowly traveling to the left over time? Platforms, projectiles, okay. More platforms. We got enemies as well. The entire game, you could make it an entire side-scrolling game. That is absolutely true. The world is your oyster. The ones that can only jump, we will actually talk about jumping later. Spoiler alert. But at this point here, for those of you guys who were able to follow along with our fairy example, which is a very short example, it's part of my pun, I just had to. We got all this, and we're going to jump into our last quick question before the exercise here. So read it over carefully, figure out where did I make a mistake while writing out this example. I'll give you guys a minute, 30 seconds to review this. Okay, let's go and give 15 more seconds, get those answers in there. Okay, let's end the polling right there. So, congratulations, a majority of you guys were able to get it. The answer is correct. We are missing that super init call. Why? Because there's some complicated stuff going on behind the scenes, and we're too lazy to type it out all on our own. We're going to use super init to go and save us all that effort. And just to show you, if I skip this, what happens? If I try skipping this and running my program, it should, throw out a really big, ugly error message down here. So, oh gosh, that is complicated. I don't want to really read that. Fairy object has no attribute, underscore sprite double underscore G. I don't really want to know exactly what that means. I'm going to guess it has something to do with the sprite groups. If you find yourself finding weird issues like that, double check. Did you go and get the key checklist for everything you need to do to go and run your program off properly? As for like draw function, there's a way you can call drawing from inside main fairy, but we don't actually use a draw function. As for the move method, that is completely optional. In fact, I might skip move and I might try a different option. That being said, who's excited to get back to programming their games? Because your goal is to go and make our exercise now into a player sprite. So I put an image right here. This is the image that you guys can use, right, to go and download and plug into your player. And you guys can call that player.png or whatever you want, but your goal is to go and basically transform the player we took from last week and create this player sprite. Or if you haven't got that done, transform the fairy that we created and create the player sprites. Also, on top of that, I'm going to get 2 bonuses. 1, can you make the player just slowly fall down over time? Which might be useful if you want to, I don't know, have platforms platforming on gravity. And 2, oops, I skipped a slide there. If you guys are really ambitious, you guys can go and try animating your sprites just by simply replacing the image. Full instructions on how to do that are in here, but make sure you go and solve bonus number 1 first. That one is much easier to do than bonus number 2. All right, sounds good. Everyone's ready to go? If so, we'll jump straight into the breakout rooms. Games folder. So, oops, my computer chose now it was a good time to start lagging up, so that's unfortunate. Let's see. I also want to make sure I can see my chat screen so I can have you guys along for the ride. My computer is really not liking me. My computer chose literally the worst time to crash. All right, sorry about that. Hopefully I'm no longer sounding like a robot or anything. How have you guys are able to follow along with what I was saying? Let me jump into it then. I'm inside the game folder here. This is not session 4's folder specifically. So as I was just trying to show earlier before my computer bugged out, I'm inside my Ignite sessions and I'm inside the game folder right now. I clicked off a brand new assets folder. I copy pasted that player image straight into there so I can go and grab it. Let's go and take a look at all the code that everyone has written, and together we can come up with a solution. So taking a look, just starting off the top of my list here, group number 2, they has a good code here. I am looking around and excellent. They have a class player. So inside there, let's go and compare some differences. They first up have that import OS line right here. And then afterwards, we have pygame.sprite.sprites. And we're going to basically get rid of a whole bunch of this stuff here. The color, no more. The rect of all those special coordinates, no more. We're going to just simply go and plug in super, but double underscore inits, double underscore. And taking a look at another group here, group number 4 has added this solution here. Oh, I'm scrolling around a little bit quickly, but I should be able to see. I'm going to keep that move speed just because I think it's useful. I'm going to go image location is equal to os.path.join, and I'm going to go assets, and I'm going to go into my player.png file here, and then I'm going to go and load it up just the same way we did before. Self.image is equal to pygame.join. Goodness, my brain is suddenly falling apart right now. Image.load. We're going to go for that image location, and we're going to just copy that convert alpha line, just memorize it. Finally, self.rect equals self.image.get rect. Get rect, son. That is a function call there. And I'm going to go and do a little bit extra here. Self.rect.x equals x. Self.rect.y equals y. We're going to set the x and y coordinates based on the input that we're getting along the way. As I'm looking around, there's this move stuff, there's this teleport stuff. I'm going to also add for completion, def, updates. And we said that we wanted to make it fall down. Oops, I missed the cardinal rule, put self as a first keyword. To make it fall down slowly, I'm just going to call my move, self.move, and I'm going to make it slowly track downwards. 0 in the x dimension, and I'm going to make it just fall very slowly, 1 in the y dimension over here. We got to take a look at the main.py file here. I'm going to scroll down. Group number 7 looks like they got a solution for how to get that working. As usual, we need to go import our player. That's already done for us. We're going to need to go and create our player group as well. So let's go and take a look around. And right, I don't actually see my player listed here for some reason. Oh, it's all the way down here after my platforms. That's why. So player equals player. Actually, that can stay just the same. I think we can keep on using this. We're going to need to go and make a group though. Players, I like to keep my groups a plural name, equals pygame.sprite.group, capital G, open, close, brackets there. And I'm going to say players dot add player. Finally, scrolling around, taking a look at this, I think I can go and pull from, what's a number? I have not tried it. Group number 5. What group number 5 has, they actually were able to keep the player just the same here. No point changing something that works already. They even made WASD keyboard work. I'm not going to add that now, but I think that for those of you who know how to do it, that's super cool. And in the update section here, it's a little bit bland. We're going to go players updates, and we're going to make it fall down slowly. Down here, we're no longer drawing a player rectangle. We're just going to draw the player image. So I'm going to say players, that group, draw. And I'm going to say, where do I want to draw it on? I want to draw it on the screen. If I did not make any typos, let's see what happens. I made a typo. I think I typed in unit, not init. That is strange. When you're trying to type at 1,000,000 miles per hour, make sure your brain actually catches up. There we go. We got our player. Oops, slowly falling down. And I forgot WASD does not work. So my arrow keys, we got it jumping around. Awesome. I'm going to go and cut off this story here. Thank you guys for coming in. As usual, we're going to go and ask you guys to go do a quick 2-minute poll. And as a reminder, for those of you who did not finish that midway feedback form, it only takes 2 minutes. First one, this is first 10 seconds poll. What do you thought of today's session? And then let us know how our last 4 weeks together been, so that we know how to make the next 4 weeks even better. Thanks, guys. Once you finish that, have a good one. I'll see you guys next week.
Bye, everyone.
Bye. Thank you.
Bye. Thanks for coming.